Good morning, students. In our last video we just started learning a lesson called to be coordination chemistry. In that we have learned what are coordination compound. The coordination compound is formed between Lewis acid and Lewis base. The bond formed between that Lewis acid and Lewis base are coordinate bond, and there are some examples we have learned under this, as well as the important theory behind this coordination compound. That's Alfred Werner, who is the discoverer of that theory, that is Werner theory, who is known to be a father of coordination chemistry. All those things we studied in the previous slide, and this video we just going to learn what are the terms or what are the definitions of important terms pertaining to coordination compounds. In this we are going to learn about what is meant by coordination entity, what is central atom or central ion, ligands, coordination sphere, coordination polyhedron, coordination number, and oxidation state or oxidation number. So let's see, these are the common terms which repeatedly come under this unit. Let's learn what are the definition of this and what is the detail behind it. One of the important term in coordination compound is coordination entity. So this coordination entity is nothing but it's an ion or a neutral molecule composed of central atom, and usually it's a metal, and the array of other atom or a group, that is nothing but it is the combination of the metal ion and the ligand. That is called to be a coordination entity. You can see that this is the metal atom CO, Cl2 NH3 4. This is called to be the ligand. Enclosing this, that is central metal atom as well as the ligand enclosed, that thing is called to be a coordination entity. And in the formula, the coordination entity is enclosed in a square bracket. So you can look at that. Here the coordination entity is enclosed in a square bracket, CO, Cl2, NH3, the whole 4. Example, they have taken K4FeCN6, that is potassium ferrocyanide. In that the coordination entity is nothing but the metal atom and the ligand which is enclosed inside the bracket. That is, the coordination entity is FeCN6 4-. When it ionizes 4K++ FeCN6 4-. That's something which at the bracket, that is called to be the coordination entity. The other example, nickel tetracarbonyl, you know the formula is NiCO4 CO4 complex. Here the coordination entity can also be the same, because there is no element at the left hand side and the right hand side, so it's a neutral. So that's what beginning it's given, it's an ion or a neutral molecule. So this is an example of ion, the coordination entity. This is an example of neutral coordination entity. The next important terminology is central atom or ion. The central atom or ion is the one that occupies the central position in a coordination entity. The central position in a coordination entity means, I have a picture here. In central position, the element, the metal atom or metal ion present at the center is platinum. And look at this here, chromium. And take this example in which this is the coordination entity, that is FeCN6 4- when it ionizes, FeCN6 4-. The coordination entity in which the central metal ion present in this coordination entity is Fe2+. So you have to calculate the oxidation number, only then you will come to know the charge of that. So here the central metal ion present in this coordination entity is Fe. So when you have the diagrammatic form, you can easily find out that is chromium, like platinum. But when you see the formula, the first element which is present inside the bracket, that is what called to be, here you can consider cobalt, here chromium, this is osmium, this is for Fe. but you need to calculate the oxidation number. So you will learn after this how to calculate the oxidation number. So including that only we have to answer, because it's a central metal or it can be iron. If we consider nickel tetracarbonyl, that's a neutral molecule, so you can say it is a Ni. The central metal atom present is Ni, but here this is not a neutral molecule. Hence we are supposed to find out what is the charge of the central metal atom. So the central metal atom or an ion, so is the one that occupies the central position in the entity along with the ligand. Now these two can be linked, that is the central metal ion and the ligands are linked through a bond called to be coordinate covalent bond. You know that the ligands are acting as a donor and the metal atom will be acting as a acceptor. Metal atom or metal ion will act as a acceptor. So when the donor donates an electron and the acceptor will accept the electron pair, the bond formed is called to be coordinate covalent bond. And the other name of the central atom or ion is called to be Lewis acid. A denotes acceptor because the central atom or ion are accepting the electron pair donated by the ligand. So A, you keep it in mind. So you can remember the central metal ion is called as the Lewis acid. The example is K4FeCN6, where the central metal atom or central metal ion in this complex is called to be Fe2+, because this can be considered to be X plus, this is negative ligand. 6 into minus 1, you will get sum of the charge is said to be 4 minus, because this ionize into 4K plus this. Minus this minus 6 go there, plus 6, and you will get the charges said to be Fe2. Next we will see about the ligands. This ligands are the atom or group of atom bound to the central metal atom or ion. Look at this complex where cobalt is called to be the central metal atom. If I find its charge, it's going to be plus 3. So CO3 plus is said to be the central metal ion present in that. So what are the L's enclosed in the coordination entity is called to be the ligand. So it could be either an atom or it could be a group of atom. So for an atom you can take an example of the Cl. Cl minus is an atom. There are two Cl. So that is Cl2. Then group of atom means ammonia, that is amine, NH3, nitrogen and hydrogen together. So this can be other than the central metal ion. What are the else which is present inside the coordination entity? Those are called to be a ligand, and you all know the ligand is otherwise called as Lewis base because it can be electron pair donor as well as it donate the electron pair to the central metal ion through a coordinate bond between the central metal ion as well as the ligand. Let's see the example. The other main, as I said, other name for central metal ion, it is called to be the Lewis acid, and the ligands are called to be the Lewis base. Example, when we take K4FeCN6, the Cn minus is a ligand because this is central metal ion Fe2 plus, and Cn minus, this is a negative ligand. So Cn minus is a ligand, but carbon is a donor atom. So you can look at the different things, like here there are nitro group, you know, NO2 is nitro group. In that, if N is donating a pair of electron to the metal atom, then the donor atom is said to be the nitrogen. Likewise NO2, this also nitro group NO2, that also NO2, but in this oxygen is donating a pair of electron to the metal atom. So the donor atom is said to be oxygen. Likewise, another example, thiocyanate. Here SCN, the thio group, sulfur is acting as a donor, but here isothiocyanate where NCS, N is donating electron, so nitrogen is the donor. Likewise, here too, another example, CONH36Cl3. Here the central metal ion is CO3 plus, and the ligand is amine NH3 and amine AMMINE. This NH3 is called to be a ligand, but in that ligand nitrogen is acting as a donor atom because nitrogen has a lone pair of electron that will be donated to the central metal atom and it form a covalent coordinate bond. Now, there is some more examples for this ligands. One is bidentate ligand, polydentate ligand. Bidentate ligand means a ligand can able to capable of forming more than one coordinate bond, same molecule. Look at that, NH2 single bond, CH2 single bond, CH2 single bond, NH2. The name is ethylene diamine. In that, this nitrogen has lone pair, this nitrogen also has lone pair. So, it can donate this lone pair as well as this lone pair. So, single molecule can make a two coordinate bond to the central metal atom. Look at this, these two, this nitrogen is donating, this nitrogen donating, a same molecule here too. Another one, polydentate ligand. Example, ethylene diamine tetraacetate. So here ethylene diamine CH2CH2N and CH2COO minus. There too CH2COO minus, CH2COO minus. So it coordinate through this nitrogen 2 bond. Next one, this oxygen, there is 3 bond. Next one, this oxygen 4 bond. And the next one, this oxygen 5 bond and this oxygen 6 bond. So a single molecule, that is ethylene diamine tetraacetate, there are 6 coordinate bond it makes. So it can be a polydentate ligand. So there are so many examples are given for the ligands. So we are just going to learn those ligands name. Normal case, all these ligands were named to be this. This is a common name which we have learned till now. From this chapter onwards, when it is considered to be a ligand, its name is changed entirely. So you know, normally bromine is called to be bromide. Br minus is called to be bromide, Cl minus chloride, fluoride, cyanide, etc. But in case of coordination compound, when we name it, this Br minus should be named to be bromido, chlorido, fluorido. This is because if the ligand carry minus charge, so the ligand carry minus charge, these are called to be the negative ligands. If the ligands carry positive charge, those are called to be the positive ligand. If the ligand carry no charge, then those are called to be the neutral ligand. So the neutral ligand naming is different from the negative ligand. Negative ligand always the name will end with O. So bromide, this E is replaced by O, bromido. Chloride, chlorido, fluorido, cyanido, hydroxido, carbonato, nitrato. But this one can name in two different way, because if it coordinate through nitrogen, if it make a bond through nitrogen and metal make a bond, then it is called to be nitrito. But if it make a bond with oxygen, then we can call it as a nitrito. Both are nitrito. The only different, it is making bond through N. So you are representing N first. The next you are writing O. So the next one, sulfato, SO42 minus, name is sulfate, we used to say, E is replaced by O. Likewise, this is sulfide, sulfido, oxalato, and this is the neutral ligand, its name to be ethane 1,2 diamine. But this is a negative ligand, here there is minus, there minus, so we just, it end with O, that is tetraacetato. Another one, this is triphenyl phosphane, and this is called to be the pyridine. So these are the some examples of ligand. You have to learn this. Next is coordination sphere. So here this coordination sphere, this is the complex ion in which the central metal atom ion as well as the ligands are enclosed in a square bracket with the net charge. That is called as the coordination sphere. Let's take an example of K4FeCN6. This FeCN6 4 minus is the coordination sphere, but the K plus ion is called to be the counter ion. That is the element which is present outside the complex, either at the left hand side or at the right hand side. So after the complex some element come, those are called to be the counter ion. The element, that is the central metal ion along with the ligands enclosed inside the bracket, is called to be with the net charge, is called to be the coordination sphere. So you can take another example of that, CONH36Cl3. So this is called to be coordination sphere and this is called to be the counter ion. Next one is coordination polyhedron. It's a three-dimensional arrangement of ligand atom, that is the ligand, if it is a neutral or neutral atom, then we can ligand atom, or ions, seen Cn minus, etc., that are directly attached to the central atom. So the central metal ion or an atom with the ligand in a three-dimensional arrangement is called as a polyhedron or polygon. So here, if it is arranged in a octahedral, if the coordination number is 6, if there are 6 ligands, its geometry is said to be octahedral, and then its polyhedron is octahedral. Then if it is 4 ligand, it's tetrahedral or square planar. So let's take an example of potassium ferrocyanide where the coordination polyhedron is octahedral. As there are 6 ligands, it's octahedral. There are 4 ligands, it's tetrahedral. So this is about polygon or polyhedron. And coordination number, the number of ligand or donor atom, number of ligand donor atoms bonded to a central metal ion in a complex is called as coordination number. So let's take this. There are 1, 2, 3, 4, 5, 6. 5 bonds are formed. So its coordination number is said to be 6. Look at this two, 1, 2, 3, 4, 5 and 6. So its coordination number is again said to be 6. So let's take an example. The coordination number is equal to the number of sigma bonds formed between ligand and the central metal atom. That's what here we saw. There are 6 sigma bond. So its coordination number is said to be 6. But when you see this, you will think there are only 4 ligands are there, right? But this is monodendate ligand. One chlorine will make only one bond. There are 2 chlorines, so 2 bond. But En is nothing but ethylene diamine. Already I showed that in the previous slide. NH2 single bond, CH2 single bond, NH2. Both the nitrogen has a lone pair of electron. It is donated to the central metal ion. So one ethylene diamine make a 2 coordinate bond. Another ethylene diamine 2 coordinate bond. Hence it form, the coordination number is said to be 6. Then example K4FeCN6 where its coordination number is said to be 6 because the Cn is a monodendate ligand. Another example, nickel, this ethylene diamine, 3 ethylene diamine are there. You know, 1 ethylene diamine make a 2 bond. So 3 ethylene diamine will make a 6 bond. So the coordination number of Ni2 plus is said to be 6. Next, the last one is oxidation state or oxidation number. You all study detail about this oxidation state, salient features and all that in 11th standard. But still, here let's see what is oxidation state in coordination compound. The oxidation state of a central atom in a coordination entity is defined as the charge that would bear if all the ligands were removed along with the electron pair that were shared with the central atom. You know that normally this coordination compound is formed between the Lewis acid and Lewis base. When all the Lewis base, each Lewis base will be sharing one lone pair of electron to this central metal ion. When all the lone pair of electrons shared by the ligands are removed, then what would be the charge gained by this central metal ion? Then that is called to be the oxidation state. So here in naming the complex, this oxidation state will be always represented in a Roman numeral. So let's calculate the oxidation number of one example. Here I have taken CuNH342+. So I need to calculate the oxidation number of the central metal atom. So I'm going to take this as X plus. Amine is said to be the neutral ligand. So its value is said to be 0. No charge, right? So its value is 0. There are 4 ligand, 4 into 0, 0 equal to, the total charge will be equal to plus 2. Above the complex there is a charge plus 2, that plus 2. So this X plus 0 equal to plus 2. So X charge would be this plus 2. Okay. This is for this copper amine complex. But here FeCN6 4 minus, as you all know, Cn is a negative ligand. So I'm going to take it as a X plus. There are 6 ligand. Each ligand has the charge minus 1. 6 into minus 1 equal to minus 4. Then this minus 6 will go outside plus 6. So plus 6 minus 4 is plus 2. So the charge of Fe is plus 2. Or when you write the naming, you have to keep this charge in Roman letter. This is about the oxidation state. Okay. Here there is another K4 FeCN6, I ionized that into 4K plus plus FeCN6. Then FeCN6, you have calculated the charge into 2, that is the plus 2 oxidation number.